I would like to, I don't want to do any new stuff today, actually. So I wanted to talk about one thing which I noticed when I was grading the homeworks yesterday. I want to talk very briefly about the random dictator method. There was a question about that on the homework, which almost everybody got wrong. So I would like to talk just briefly about this. So this is an old thing, but people didn't do so hot on it on the homework. So the random dictator method, just to get the concept, is everybody votes, and then you can imagine you like put all the votes in a hat and just choose one out at random, and that vote is the winner. So one vote is chosen at random, and then that one all by itself determines the winner. All right? And there was a question on the homework about if I have these. So let's just do one example that's like the homework question that most people didn't do correctly. It's not very complicated. It's just I wanted to do another one to make sure everybody's with it. So let's say 4 people voted A, B, D, C. 7 people voted C, A, D, B. 5 people say B, C, A, D. 1 person says D, C, B, A. This looks complicated. It's really not. Okay, so let's say these are the votes. Now, I hope everybody knows what this is supposed to mean. I mean, by now you should know. What that means, for example, is there are 4 people who voted in this way with A on top, and then B, then D, then C. There are 7 people who voted in this way, and so on, all right? And you have to imagine, I take all of these votes, put them all together in a pile, and pick one out at random. And who's gonna win? Of course, the answer is, I don't know who's gonna win, because you're gonna choose the vote at random. So you can't say who is going to win here, but you can give, so this is a typical question I might ask, and this is the question that was on the homework. Give probabilities for each candidate to win. So you can't tell me who is going to win because it's going to be a random choice, but you can say something like, you know, A has a 25% chance of winning or something like that. Give probabilities for each candidate to win, all right? And all of these probabilities are based on, your answer is going to be like A's chances are something out of something, which you can write as a percentage if you want to, but it's not necessary to write as a percentage. And sometimes you need a calculator to write it as a percentage. But A wins something like, you know, your answer is basically going to be a fraction, something out of something. And what exactly is each thing there? You imagine I'm choosing one of these votes at random out of a pile of a bunch of votes. The something out of something will be how many of those votes actually are votes for A out of how many total votes are there in the pile. All right. So can anybody say how many total votes are there in this election? I'm choosing randomly out of some bunch of votes. How many total votes are there? Or you could describe to me how you would figure that out. Here's a hint. It's not 5. You might say, oh, there's like 1, 2, 3, 4, 5, but it's not that. 21? Yeah. How'd you get that? You should count up. You should add up these numbers. Is that what you're saying? Yeah. Right. There are 4 voters here. There are 7 voters here. So when it comes to the total amount of votes, you should be adding up those numbers. So the total number of votes is, 4 plus 7 plus 5 plus 1 plus 3, which is, so that's 11, 16, 17, and 3 makes 20. I think it's 20. All right. And when I want to know the chances of A winning, there are 20 total votes that I'm choosing from at random, and 4 of them have A on top. And so A's chances are 4 out of 20 have A on top? So A's chances are 4 out of 20, like that. All right? And if you like to write things as percentages, you can plug that into your calculator. You do 4 divided by 20. You get, I did this ahead of time, you get 0.2, otherwise known as 20%. All right? This is how you figure out the chances that each candidate has of winning. It's how many votes did they get with them on top, divided by the total amount of votes that you're choosing from at random. All right, so A has a 20% chance of winning. And then you just say the same thing for the other candidates. There's no tricks really. B, their probability is, again, it's out of 20, so it's, as a fraction, it's something over 20. What is the numerator? It would be how many of these votes have B on the top. What do you say? 8, yeah. I have these 5 people put B on the top. These 3 also put B on the top. So the total number of votes with B on the top is 8. So B's probability of winning is 8 out of 20, which if you put this into your calculator is 40%. Now, if I ask this question on the test, I would not expect you to actually do the division. You would just leave your answer as that fraction, 8 divided by 20. I don't care if you could reduce the fraction, I guess, to, I don't know. I don't care. 2/5 is that? It doesn't matter. 8 out of 20 is totally fine. Anyway, B is going to be, looks like 7 out of 20, because I have 7 votes for C. C is what I'm talking about. 7 out of 20. All right. This, if you do the numbers, is 35%. D is going to be how many for D? 1. 1 out of 20. That's 5%. All right. And this is, that's it. Those are my answers. All right. The question was, give me probabilities for each candidate to win. And that's what these numbers are. So it's 20%. Sort of, those are the probabilities. All right. And if you are doing this correctly, those numbers should add up to 100%. And they do here. If they don't add up to 100%, something has gone wrong. A lot of the answers that I read on the homework, they were like, A has a probability of 75%, B has a probability of 75%, C has a probability of 75%. It doesn't make sense if those numbers don't add to 100%. You're really telling me that everybody has a probability of 75% of winning? It don't work that way. All right. Are there any questions about this? This is it's not a hard thing to work through if you know what you're doing. I hope everybody agrees. All right, that's the random dictatorship method. Not a crazy way of doing things in real life, although it does sound a little crazy. All right, great. You just pick winning ballot at random. What I want to do today, I do want to save some time to talk about the test, but I just want to do 2 more examples of this gerrymandering districts thing that we have been talking about last time. This is what, there are several examples on the homework of things of this nature. I have 2 more examples that I want to do today, and then we'll talk about the test, and that'll do it for us. Although these 2 examples may take us a few moments to do. I got pictures. What we have here is a map of our dear Fairfield University campus, on which I have put some little symbols. All right, I got this in here too, somewhere. Gimme. Cancel. Okay, so here is a picture of, this is a map of the campus, And I have put these little stars and circles on here, imagining that these are like voters that we're going to divide into districts. This is like, for our student elections or something. Do you have political parties for those? I don't think so. I don't actually know. I don't get involved. But I went to grad school at UCLA, and they had like very sophisticated campus politics for like their student body president or whatever, and they actually had political parties, which I thought was a little crazy, but that's how they do it at super big schools, I guess. Anyway, what we have here is 50 voters total. Some of them are the circles, some of them are the stars, and if you count them up, you will see there are 20 stars and 30 of the circles. And we are going to make 5 districts out of them of 10 voters each. And remember, the whole deal here is, what are all the various different ways that I could draw the lines which makes this or that different outcome in the election as a whole, in terms of how many districts do the stars win versus how many districts do the circles win? Those are the kinds of questions that we're going to answer. So if I show you one of these, like on the homework or also likely on the test, there are 2 kind of major questions that I could ask you about such an example. First would be and these are 2 separate things on our big checklist in case you care. First would be to determine the possible outcomes after drawing the districts. All right, determine the possible outcomes. What I mean is there's going to be 5 districts. Is it possible, for example, that the circles win all of them? Is it possible that the stars win all of them? Or can it go, 4 circles and 1 star? That kind of a thing. That's what I want to think about first. That's what I mean when I say determine the possible outcomes after drawing the districts. So without thinking about anything at all, just because there are 5 districts, the possibilities must be, and this is how I would suggest you start. Before I think about the numbers or anything, the possibilities could be, it could go 5 and 0, so maybe 5 star, 0 circles. Sorry to use a circle, which also looks like the number 0. It could be 4 stars and 1 circle. Right? It could be 3 and 2. It could be 2 and 3. This I'm not thinking about anything. I'm just writing down what are all, if there's 5 of them, these are the various ways that it could break down, right? 5 and 0, 4 and 1, 3 and 2, 2 and 3, 1 and 4, or 0 and 5. All right? This is just like, in theory, these are all the ways that it could go. But some of these are not going to be possible based on the numbers of how many voters we actually have. So which of these are possible? This is based on the way you want to think this through is about the threshold to win in each district. So each district has 10 voters. This is what I said before. Now we're actually going to start thinking about the details of this particular example. So each district has 10 voters. The threshold to win a district is, how many do you need to win in each district then? 6, yeah. If you get 5 in a district, that's a tie. I don't want to talk about ties though. In order to win a district, you need 6, right? So the threshold to win in each district is 6. So now we can talk a little bit more intelligently about which of these possibilities are actually possible, right? And that's based on this, what I said here. We have 20 stars and 30 of the circles. So we have 20 stars So the star can win up to districts. Anybody want to say? Because there are 20 of them, you need 6 in order to win in a district. How many could the stars actually win? I saw somebody whisper to themselves, in their heart perhaps, 3. The answer is 3. They can win 3, which would require 3 times 6, which is 18. And that's actually possible because they have 20. So they can win up to 3 districts. That's because, you know, what's important here is the threshold and then the number that they actually have. All right, they could win up to 3 districts. This is because 3 times 6 is 18. And they have 20. So it is possible for them to win 18. It is not possible for them to win 4 districts, though, because that would require 4 times 6, which is 24, and that's more than they have. All right? So the star can win up to 3 districts. And what about the circle? We have, this is what I told you before, 30 circles. So the circles can win up to, what do you say? You want to show me the fingers? They need 6 each. Anybody got the fingers? I see some fingers. You should think about various multiples of 6, right? Could they win 3 districts? That requires 18. They have 30, so they could win 3. Could they win 4? That would mean 4 times 6 would be 24, and they have 30, so they could win 4. Could they win 5? 5 times 6 is 30. They do have 30, so I think they could win 5. So the circle here, I saw some people giving me the fingers, win up to 5, right? 5 would require 5 times 6, which is 30, and they do have 30. So they just barely, they could win up to 5, all right? And now all of these words that I've written are enough to tell me exactly what are the possibilities. Look at this big list here. Some of these are not actually possible. We said the star can win up to 3. That means, like, this is possible, but this 4 and 5 star are not possible. So I'm going to sort of X out these. And the circles can win up to 5, so I don't have to X out anymore. I mean, they can win, like, even this one, which is fairly extreme, is still possible. So these here, these are the possibilities. These are the possible outcomes. And this is what your answer should look like when I'm asking you, determine the possible outcomes. All right. My suggestion would be just write down like all possible eventualities and then eliminate some of them because of this business over here. All right. This is how I would reason this through. Any thoughts about that? This is determining the possible outcomes. Okay, now let's try to actually draw these. So now this is like the part B of the question or something. Let's try to draw the ones that are possible. All right, and your strategy, so there are 4 possibilities that I circled in the red there. This, and this, right? So there are 4 different things that you need to draw for this part of the question, and that's why I gave you so many on the paper there. Maybe I'll try to do one all together, and then I'll let you guys try and do the other. So let's try. Let's do 3 stars and 2 circles. All right. This one is only just barely possible because, remember, if you're thinking about the thresholds, the 3 stars requires 18 star voters, and there are 20. So it is possible, but there's not a lot of wiggle room there. So anyway, I'm going to get my picture back. All right. 3 stars and 2 circles. I don't know if you looked carefully at the map. It seems to me like the map actually kind of neatly, all the stars are kind of bunched together already, which I don't know if this strikes you as unrealistic. It is. I'm trying to make something which is vaguely realistic here in real life when it comes to like Democrats and Republicans. When you look at where they live, actually, they do not live sort of evenly dispersed across the map. There are bunches of Democrats together and sort of bunches of Republicans together. The way that it typically works in the United States today is that the cities tend to be dominated by Democrats and the country tends to be dominated by Republicans. And so when you look at real life maps, they actually kind of do look like this, where certain parties are clustered in various areas. So this is not altogether unrealistic. Anyway, can we do 3 stars and 2 circles? This is going to be a little tricky, but I am going to let's try to pack 2 circles, then let the star, I will say, then make the star win the other 3. All right. Remember the basic strategies when you're trying to draw these is what they call packing and cracking. I'm going to try to pack 2 districts full of circles. That means make districts which are almost entirely circles to get them to their 2, and then hopefully it won't be so hard to make the stars win the other one. So remember, the districts are supposed to be 10 voters each. So I'm going to make 2 which are just all circles if I can. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put those all together, something like this. I think that's 10, right? These can be a little annoying. You have to count and make sure. Yeah, this is 10 over here. So the circles win in that district. Here, the circles are winning that one. And then I would like to pack another district full of circles. Maybe I'll take some sort of these bunch at the top here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I should get this guy too. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Of course, you don't have to draw your lines exactly where I put mine. Like that. All right. There's another circles district. All right. I packed 2 of them full of circles, and then I'm going to try to make the stars win in the other 3. Now, it might be tempting to just make this, what I'm about to do is not quite right, but it might be tempting to just like make that a district. I just circled these guys. This is actually a bad idea though, because if I use up all of these stars here, I'm not going to be able to make the stars win all 3, all right? These groupings here, I'm going to make 3 groups out of these. You have to make it so that the stars win all 3 of them. So, and in order to win, remember, you need 6 of them. So I'm going to try to take, of these bunch of stars in the middle, I'm going to try to take only 6 of them and then add those together with 4 circles. So maybe 1, 2, 3, 4, 5, 6. Something, you have to do something a little weird here. Maybe like there are 6 and then 4 circles. All right. This is going to be won by the stars, just barely. 6 stars and 4 circles. All right. And I'm going to do a similar thing on the other sort of this batch of stars. You do not want to put them all together, because then the circles might have a majority in the leftover bit. So I'm going to take, again, 6 of these stars grouped together with 4 circles. So 1, 2, 3, 4, 5, 6, something like this. Those 6 stars and then 4 circles. How about that? This is another star district. And then we have a weird snaky shape which will capture the rest. And that's another stars district. All right, and I did it 3 stars and 2 circles. I'm using some very weird shapes there. That's because this is a weird outcome. In my opinion, the most natural outcome would be 2 stars and then the rest circles, because that's where they naturally group in the map as as it is. All right. I would like for you guys to try to draw the other types of outcomes. So I did 3 stars and 2 circles. That's on the list. That was this first one here. See if you can draw the other 3 possible outcomes. 2 stars and 3 circles, which I think is the easiest actually, is the next one. 2 stars and 3 circles. And then 1 and 4 and 0 and 5. See how it goes. I will walk around and see how you're doing. Make sure every one of your regions has 10 little guys in it. Okay here? So the circle's still in here. The stars, negative 1 is there's 7. Yeah, I think that's still good. Yeah, there's always, like, my particular lines that any other way to do it. Correct. Okay. this example. You want two regions where the stars win. It looks to me like the stars are already kind of naturally. If you just make them that region, and you get two regions for the stars. Well, you can leave this like it is, but make these other stars into a region. Not take it possible. Doing good here? Yeah. The problem is there's too many. You only have 10 each. So I would suggest just take these guys off the list. That's already 10. That's called packing these stars. Those ones you have to crack. Split them apart into 4 little bits. Yes, so that they won't actually. Maybe we could talk about these. I see some people making good progress. I don't know if that was really enough time to do all 4 of these, but I do want to get onto, I wanted to talk about one more example and then also talk about the test. So let's try and keep it moving here. So that was 3 stars and 2 circles. What I said, in my opinion, the easiest one, or the most natural one, is to do 2 and 3. So 2 stars and 3 circles. The reason I say that's the most natural way to do it is because when you look at the map, the stars already live in kind of 2 separate clumps. So the most sensible way to do this would be, and in the middle, there are actually 10 here. So I'm going to take that as one of my regions. The stars win. And then the other clump of stars, there's also 10 over there, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so these guys also are going to be a group. Those are the 2 star regions, and then just however else you want to divide up the rest, it's going to make 3 circle regions. So maybe I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll take these guys as one region, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those guys, and those guys. So I think this is what I said for this one. I hope I counted up the numbers right, but this is 2 stars, 3 circles. All right, that's the most sort of natural way to divide it up this map. Any thoughts about that? All right, let's try 1 and 4. So 1 and 4 is a classic packing and cracking kind of strategy. 1 star, 4 circles. The strategy here is pack the 1 star and then crack the rest of the stars. So as I was walking around, I saw most people packed this one region over there. So that's one region that the stars win, and it's packed because they are all stars. It's not a mixture. It's all stars. And then the remainder, the basic idea here is what's left over. I have this clump of stars in the middle, but I'm going to crack them sort of into 4 pieces, something like that. Now, I don't know if those, you have to count and be careful that you actually get 10 in each, but this is the basic strategy here. The other clump of stars, I'm going to break into 4 separate regions so that they can never win in any one of them. And now I'm going to try and be a little more careful with the numbers here. So I'm going to maybe take 2, if you crack this into 4 bits, then you're going to take like 2 or 3 in each piece. So I'll take those 2, and then 1, 2, 3, 4, 5, 6. How about 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do like this. Of course, there are many ways you can do that. So that's 1. And then maybe I'll take 1, 2, 3, 4, 5, 6, 7, 8. 8 circles and 2 stars like that. And then I'll grab 1, 2, 3, 4, 5, 6, 7, and 3. So maybe this. No, I don't want to start. A little something like that. I think that'll do it. Many ways to make this work, but I pack the stars into that one on the left, and then the stars in the middle, I crack them up into 4 regions so that they can't win any of them. Any questions about that? I hope everybody did something like that. All right, and then the 0 and 5. So this one is like cracking everything. 100% full crack. This would be 0 stars, 5 circles. All right. That means every region of the stars has to be broken up, and you have to take stars basically 4 at a time is my strategy. You can never let the stars get 5 or 6 in any region, because then they would either get a tie or they would win. So I'm going to take of the region, and this you have to use some pretty weird shapes to make it happen. But of the bunch of stars on the left side, maybe I'll take those 4 of them, and together with 6 other circles, I'm going to try to make every region so that it has 4 stars and 6 circles. So 4 stars there, 1, 2, 3, 4, 5, 6 circles like that. All right, so that's one region. Then I'm going to take, again, 4 stars and 6 circles every time. So I'll grab these. How about those 4 and then 6 circles? 1, 2, 3, 4, 5, 6. How you like that crazy shape? This is what it takes to get weird outcomes like this. And then again, 4 stars and 6 circles. I'll take 2 stars there, 6 circles, and then 2 more stars like that. All right. I'm feeling pretty good about this. There are other ways you could do this, of course, but this is my way. 4 stars. So here I cracked the remaining stars, 4 and 4, and then you just need 6 circles with each. So maybe like that. All right. This one, and then this one here. There you go. This is 0 stars, 5 circles. Maybe this is the weirdest of the outcomes. You have to use very strange shapes to make that work out. Any thoughts about that one? Questions? All right, excellent. Let's just do one more example. We don't have time to do it fully, but we can, at least let's talk about what are the possible outcomes, and then maybe we won't have enough time to draw them. This is a fairly realistic, I created this. This is my own, somewhat unscientific, but based on reality. This is a map of the state of Connecticut with similar little guys to represent voters of either Democrats or Republicans. If we had more time, we would do the same business. Tell me the possible outcomes and then draw them, but I think we're not going to have time to do the drawings. All right. So let's look at the Connecticut districts. So like I said, this is inspired by real data here. I took a map of the state of Connecticut and voter registrations based on Democrats and Republicans, and I kind of translated that into this bunch of boxes and stars here. And if you count them up, which I don't suggest that you do, but I kind of rounded the numbers off so that this would work out nicely. This has 50 boxes, and these are the Republicans, and it has 100 stars, and these are the Democrats. And this is roughly realistic picture of where the Democrats and Republicans live in the state of Connecticut. There is kind of a concentration of Republicans around here. This is like sort of country. This is kind of like upscale country living, like fancy celebrity type country Connecticut houses in this region. Otherwise, the Republicans, I mean, they exist everywhere, but they're kind of dispersed in other parts of the states. Here is almost all Democrat. This is like the Hartford area, which not coincidentally, is where a lot of non-white people live who tend to vote for Democrats. Anyway, can we discuss, I sort of rounded these numbers off so that we would have nice numbers here. Let's make 5 districts. of 30 voters each. Connecticut in real life does have 5 congressional districts, and you have to make them having roughly equal populations. So I would like to make 5 districts of 30 voters each. And let's just talk about what are the possible outcomes, just because we are not going to have time to draw all the pictures. What are the possibilities? All right, this is just like the one that we just did. I would start off by just writing down a list of just every possible eventuality. We could have 5 Ds, 0 Rs. We could have 4 Ds, 1 Rs, and so on. 3 and 2, 2 and 3, 1 and 4, or 0 and 5. But some of those are probably not possible, but that's just without thinking about anything. Those are all the eventualities that could, in theory, exist. The question is which are possible. And you think this through based on the threshold to win in each district, right? Each district, I said, has 30 voters, right? 5 districts of 30 voters each. Can anybody say what's the threshold to win a district? Each district has 30 in it. So how many do you need to win? I think 16, yeah. Out of 30, if you get 15, that would be a tie, right? In order to actually win, you would need 16. So the threshold to win a district is 16. That's because each district is out of 30. If you got 15, that's a tie, but 16 would be a win. So the threshold to win a district is 16. And in terms of what's possible, you should be thinking about various multiples of 16. I know this is kind of a pain, but let's talk about the boxes. That is the R's. The R's have 50, so they can win up to. You just have to think how many multiples of 16 can you actually get from 50? So 1 would be 16. 2 times 16 is 32, so that means they can win 2 because they have 50. That would only require 32. 3 times 16 is 48, so they can win 3, but they cannot win 4. Because 4 times 16 is 64, which is too many. They only have 50. So the R's have 50, so they can win up to 3 districts. And this is because 3 times 16 is 32, but 4 times 16 is 64. Not 32. That's 2 times 16. Is 48. All right. On our test, I would give you, this is kind of annoying to multiply by 16. I'd give you smaller numbers probably. All right, so the R's can win up to 3 districts. It is not possible for them to win more than 3. And the D's have 100, so they can win up to, I think 5. 5 times 16 is still less than 100, right? So they could actually win all of them. Did I write down? 5 times 16 is 80. And so it is actually possible for them to win all 5 of them. So in terms of the possibilities over here, I am going to rule out some of them. I said the R's can win up to 3. It means the R's cannot win 4 or 5. So these 2 here are impossible. So as far as my final answer, those are impossible. These are the possible ones. All right. Because the R's cannot win more than 3. And if you like doing this kind of a thing, you could try and draw the pictures. I mean, this would be good practice for the test. See if you can actually draw those 4 outcomes there. This one is harder than the one we just did just because it's kind of a pain. There's 30 voters in each district, so when you're counting them up, you have to actually make sure it adds up to 30 every time, which is a little annoying in my opinion. But I wanted to do one that was a little harder. All right, any questions about that? I think I would like to talk about the test for at least 4 minutes. So everybody, I hope that you all are clear on how the test works. When you come, I will hand out all questions to everybody, but you should only do the ones that you need to do. That is the ones that you don't already have full credit on. So I hope that you all still have a copy of the checklist that I gave out on the first day of class. I'm talking about this thing, right? If you don't still have it, you can print one out for yourself at the class website. You should bring the checklist with you so that you know which questions you are going to be doing on the test. Please don't ask me during the test, did I get this one right last time? I will say, I don't know. I mean, I do know. I have them written down in my computer, but I don't want to deal with working those out. Certainly, if you have lost track and you aren't sure which ones you have credit for, let me know, ahead of time, and I would be happy to tell you. But don't ask me during the test. So maybe I only have time to tell you what will be on the test in terms of the topics. So the test will include all topics through number 17. So maybe I will just refresh our memory about what the new ones. The new ones are, number 11 is random dictator. Number 12 is approval voting. Number 13 was, this is about weighted voting, the dummies, dictators, veto power. Number 14 was the Shapley-Shubik. And number 15 was the Bonshoff. Unfortunately, you need to remember the difference between the Shapley-Shubik and the Bonshoff. There are two different ways of doing it, with no clues from the names. Then we had the number 16 was gerrymandering, the possible outcomes, which is what we just did. Thinking about the thresholds to win in each district. And then number 17 was draw the districts. The packing and cracking strategies. All right. So those are the new ones. So when you get the test, everybody should be doing these questions, right? And then based on your past performance, you may also need to do some of the other ones. Anybody got 2 minutes worth of questions about any of these things? It seems, yeah. These topics right here are weighted voting. Yeah. All right. Like I said, please let me know if you've lost track of which ones you have credit on. I would be happy to tell you before the test. And bring your checklist with you to the test, but I hope that you haven't written a bunch of other stuff. I don't want you to use that paper as a note card or something. So just the checklist, no other extra nonsense. All right. I think that'll do it then. See you Friday. Do the homework for tonight.